All right, welcome. Thank you very much for joining the IIoT World Energy Day. And we are on this particular session, we're going to be talking about computer vision, AI, and the digital grid. Hopefully you will get a lot out of it because we have two incredible professionals. One thing that I did learn, and what I am continuously learning, is that this industry is changing dramatically. The innovation that's impacting this industry is spectacular, and quite frankly, will make our lives a lot easier. Once again, thank you very much for attending the IIoT World Energy Day. All right, before we get going, we've got to lay the foundation. The two wonderful panel participants that we have, Shamik and Jay, why don't you give us a little background, Shamik, on who you are and why you're such an incredible person. Thank you, Ross from Toronto, Canada. Glad you're here. Go.
Thanks, Scott. Yes, hello, everybody. I'm Shamik Mehta. I'm a marketing director for industry solutions at Hitachi Vantara. I'm based in the San Jose, San Francisco Bay Area. I've been there for a number of decades now, 30 years. I've been with Hitachi Vantara for about 5 years. Before that, I spent about 6 years in a renewable energy company called Sun Edison. And before that, I spent about 16, 17 years in the semiconductor industry. I've held roles in everything from semiconductor manufacturing and design to renewable energy product management and marketing and IoT software, which we were using back in our solar energy days since 2011. Happy to meet you all.
Yeah, it's heck of a summary. Jay, I would hate to follow Shamik, but I know you're going to do a great job. Give us a little background on who you are.
Yeah. Good morning, good afternoon, and good evening, guys, from wherever you are. My name is Jay Jayaraman. I'm with Hitachi Energy, been with Hitachi Energy for about 10 plus years now. I take care of the global practice for asset performance management and IoT solutions primarily. And yeah, focusing on the energy side, transmission, distribution primarily, and also venturing into generation and other stuff. I spent about 10 years prior to that on the retail side of the energy business, deregulated, regulated, and transitioning markets. And looking forward to having a productive conversation with you all.
That is fantastic. Absolutely wonderful. And I want to make sure that everybody out there who is on this particular panel or participating in this session, it is key. It is vital. It is so important that you pepper this panel with great questions so that they answer your pressing challenges, get the most out of it. It is a platform that encourages collaboration, and that means you have to ask difficult questions. Don't worry about them. They can handle themselves. So with that said, remember, participate. All right, let's get cracking with the presentation. Can you start rolling with that, Shamik?
I can. So
Excellent.
Thanks. We're just going to talk a little bit about the growing role of computer vision and the need for remote inspections and monitoring solutions. We've seen our customers ask us for these solutions. You, audience, you may have seen lots of announcements in this space as well. The growth of drones and helicopters, even satellite-based imagery that is being used for vegetation planning, cut planning. So there's a lot of need for being able to look at what's happening somewhere from a remote location and be able to take action automatically or have some sort of intelligence tell you what to do next. And I think Jay also is saying the same thing. We work very closely together, Hitachi Vantara for all the digital and IT technologies and solutions, and Jay for his long tenure at Hitachi Energy. And Hitachi Energy, as you know, has most of the world's largest utilities as their customers. I'm sure, Jay, you must be seeing the same need. Are you seeing the need for that automation, remote inspections need?
Oh, yeah, absolutely. Particularly with the additional demand for energy and the aging grid. A lot of the utilities are looking at smart and efficient ways of optimizing their O&M and also looking at expanding the life of assets and
Right.
optimizing the capital planning, right? So there is an ever-changing demand for automating the inspection process, simplifying the inspection process, eliminating errors, if you will. So there is a great initiative, particularly this day and age, EVs.
Yeah, we see that a lot too. In fact, I think I have a slide that's the next one, the visual, just to set the tone about why people are needing a computer vision like application. So Scott, if you can move to the next slide, you'll be able to see that the main reason people need some kind of guided or automated AI-enabled inspections methodology are to understand things like, which of my assets are going to need inspections? How do I even know that I need to look at something? How do I prioritize where I need to send a repair crew? How do I minimize the costs and efficiencies, maximize efficiencies that are required for that? If they have to do any capital expenditures, where do I spend first? What's prioritized? I mean, everybody would like to fix everything by throwing money at the problem, but the thing is, not all the money is available at all times. The priority is necessary. And then there's a workforce talent gap. Just because you have a lot of cool tools that someone like Hitachi Vantara, Hitachi Energy has, does not mean they can easily be adopted by many people, because you need to train people to use it. People have to get used to it. It takes a while. Sometimes it's expensive. Whatever happens, it can be complicated. So lots of reasons why people need these kind of inspections. That's what we see. Jay and I have both witnessed this firsthand ourselves. We're talking to customers all the time. What we did with that is we decided that the two companies, Hitachi Energy and Hitachi Vantara, we launched a portfolio of solutions to address this space. So we created a set of Lumada applications, 4 different applications that we can collaborate on. And the two companies with 2 products each are helping our customers solve this problem end to end. Jay, you are aware that you have the vegetation management program where you are taking satellite-based imagery. We have the analytics abilities at Hitachi Vantara, where we can take in any image, whether it's from a video, whether it's from a still camera, whether it's from a LiDAR image, or whether it's from an IR camera, infrared, so thermal images, and we can extract information out of it automatically by processing thousands of photographs in seconds or milliseconds. And that's the power of AI, and it takes human beings just too long to do it. I think, Scott, you yourself used to work in this industry, right?
Oh, yeah, absolutely. And I was just getting ready to pop a question. So this is all great. This is wonderful. And I understand if you could lay the computer vision definition down for all the participants, and then I'm going to follow up with a question. How do you define computer vision?
It's an ability for a program behind the camera to decide what it has looked at. So it's like a human being, but instead of a person looking at it and deciding, I'm looking at a photograph of a cat, the computer decides that it's looking at a cat.
Yeah. So your computer vision is the eyes of AI.
Correct.
Right. It's just sort of it. Like we take it for granted as people that we analyze images, and then you're putting that into the hands. So from a utilities perspective, just right. Overall, from the utilities perspective, what does this give me? How do I gain from this?
Yeah, good question. Well, first, you try to eliminate, can't completely prevent it, can't completely eliminate it, but you try to minimize as much as possible risky inspection methodology. Like you don't have to climb a tower anymore, hopefully, or you don't have to hang out of a helicopter.
You don't want me to climb that tower anymore. You're going to have to rip me off with a rope of some sort. I'll be out of breath.
I know you used to enjoy doing that work, didn't you?
Oh, yeah. Yeah, it was good. It was good stuff.
Yeah,
but no, it's about reducing those costs and reducing the inefficiencies, reducing the risks. It's not a fun thing to do, to climb those towers, I'm sure. Or, flying out a helicopter and then hanging from it to take photographs of your instruments to try and see, or detect a bird's nest somewhere. I don't think those are easy tasks. I feel badly for utilities and the crews that they have to do that.
I think you can categorize into 3 different sections at a very high level, right? One is efficiency. Humans are able to do it, but it takes a longer time to do it. And with the acceleration of technologies and digitalization, we are able to do it at a much, much faster and rapid pace. The second part, as Samik said, is the safety aspect, right? We are able to avoid any of the incidents. And the third part, of course, is historically, we are looking at about 20 to 30% errors in visual inspections when it's manually done, right? So most of these principles around computer vision and AI is percentage deviation based on what is considered a golden or a rated imagery, right? So AI is able to automate that process and eliminate and get it to close to 100% accuracy. 3 fundamental categories. If I have to simplify that, if you will.
I have to ask the question. It's on the line of trust. Old school guy. I'm going out there. I'm climbing the tower. I'm looking at that asset. I see it with my eyes. There's a problem. The skirt is cracked, whatever it might be. I take that and I write it down on a piece of paper. But I feel confident that that insulator needs to be replaced. How can you ensure where this future is going about trust and being able to sort of accept that?
Again, it's got to do with the fact that technology has progressed so well in the past few years when it comes to image analytics and computer vision that the results are speaking for themselves. So, for example, you may have heard stories about how AI is able to catch cancers in lung cells from X-rays and MRI scans faster than doctor scan, or often when human beings have missed them. It's not often that happens. Luckily, that means we got good doctors. But every now and then, if you have a large data set, a human being may miss it. Computer vision has progressed to the point where it does not make those mistakes. And it took us a while to get there. I mean, we had to brute force teach computers how to look and how to read what it's looking at and understand it. But we are at that stage now. So the results are speaking for themselves because we have a large degree of confidence on the image that you're looking at in both identifying it and finding a defect from it. And because the program that we have always allows for a human being to come in and change the results. So
there you go.
A human being can verify whether the computer has flagged is a genuine error or not an error. And every time it does that, the program learns. So the machine learning model becomes smarter for the next time.
Yeah. So when we start talking about the analyzing these photos, analyzing these images, the platform says, yeah, that's good. No problem. Spit this one out. It looks like there's a problem. That can have a human interface, right?
Yeah, exactly. In fact, if you go advance 2 slides, please. It talks about image-based inspections. And right here, if you look at the middle box on the top row, it's called human in the loop. And the human in the loop is when the model says, hey, I have about a 60% confidence that what I'm looking at is a cracked insulator, but I'm not 100% sure. Can you verify the other 40% for me? And a human being can look at that and accept or reject what the computer model picked up. And in doing so, it reinforces the model and the model learns to do a better job next time.
What about, and I'm sorry, Jay, I'm geeking out on this just because I know that this is great. The processing of these images are fantastic, and it's only getting better. Thumbs up. But what I see there in the human in the loop is a increasing queue. It's like a queue of action items. Jay, how do I, from an organizational perspective, say, oh man, I've got a queue of things that I've got to figure out and prevent the classic pencil whipping of saying, yep, it's fine.
Yeah, that's one of the biggest concerns for utilities in terms of how do I optimize my manpower? Is it going to create additional work for my workforce in terms of managing their current stream of work along with just maturing the solution, right? And that's been the case when we kind of rolled out solutions to go from time-based maintenance to condition and predictive-based maintenance as well. And now eventually marrying the technology side of the house with more moving into a condition-based optimized maintenance, right? So the key part of it is the learning process. One is trying to do a retrospective analysis of their practices over the last 20 years, which has been very successful, and marrying some of their maintenance decisions and the replacement decisions to what the tool can predict or retroactively predict based on the imagery, video imagery, etc. And also looking at a couple of foundational principles, which is part of the solutions I'm seeing in the space and we see in the space. One is what we call an availability index, right? Do we have enough content and data to provide what essentially becomes an availability index? And then secondary is what becomes a confidence index. Do I have enough confidence in the assessment? So when we do solutions based on imagery, it is based on metadata management, right? So we are able to leverage a lot of imagery from, for example, Esri. standard images. If you have a structure, this is the nature of the structure. If you have a cavity or a crack, this is the acceptable limits. If you have a clamp, if you have an angle, the rust. So we do have standards that is published in the industry. So we cater to what is called a Pareto principle. 80% of the time, we wanted to provide you with an accuracy based on 20% of the data we got. And then the remaining 20% where is where the human in the loop comes in, which continuously improves your metadata. It is like building a process, spending a little bit of time initially to leverage and increase efficiencies in the long run. And the tool and the solution learns with you over a period of time.
But Shamik, I have an enterprise asset management platform. I got to work, man. I got a backlog over here of work that needs to be done. This insights, this AI platform, does it link with existing, and does it pull? Like, you know, there's a push and a pull. Does it work that way?
Yeah, it does. In fact, if you back up one slide, I'll just set the context a little bit. The Lumada Inspection Insights portfolio is a combination of 4 different products. One of them will analyze pictures. One of them will analyze video, LiDAR, and thermal streams. One of them will analyze pictures and video from satellites. And a 4th one puts it all together in an orchestration environment, which is called the Hitachi Map. That's at the bottom. And Hitachi Map allows you to view work orders in an area, check where your crews are located, check what assets are located in that area, and draw exactly how many work orders need to be worked upon in the next few days, who's going to work on them, and you can combine and merge work orders and with according to the field crews that are out there. So you can launch your FSM and your enterprise asset management strategies all from one tablet, one pane of glass, without having to log out of one system and log into another system or having multiple tabs open. Just on a tablet, you can see your in-field network of assets, people, work orders, and combine all of that data, the OT data, the sensor data, the assets that you have, all of that along with your actual work orders, and be able to combine and optimize your workforce management.
Yeah, I'm digging that. I'm digging that solution, and it can only help improve the predictability of an asset, the health of that asset, as you start pulling in all of these various data sources. It only helps.
Yeah, exactly. And Jay, for example, he's been working on asset performance management solutions from Hitachi Energy, and these are some of the best asset performance tools anywhere in the world. And we've worked in this industry for a long time, and it's not an exaggeration when we can say we really don't know how to understand what that asset is telling us, because we've been building it for dozens of years. And we've been listening to them, we've been instrumenting them, we've been making the same stuff that utilities are using either from us or from somebody else. And we've understood how to detect when they are not feeling well, when they're not performing optimally. So asset performance is at the heart of this. This is meant for enterprise asset management, right, Jay?
Yeah, absolutely. It's all part of this one integrated, what we traditionally call the connected asset lifecycle management process, right? We've got this imagery, we've got this infrared cameras, we've got the sensors, monitors, SCADA data, all your asset infrastructure data, your nameplate, etc., feeding in continuously and providing a holistic view in what essentially is a map, right? So which enables the APM to do what if analysis. What if I defer my maintenance? What is my risk exposure, right? How can I actively influence my CMs and PMs, right? Can I defer my cycle from a 6-monthly cycle to an annual cycle based on my patterns? What does it save me in terms of that? Or like aging, for example, if I don't do maintenance on my high voltage transformers and I load it significantly, what am I looking at in terms of my determinant for aging? Am I going to lose 6 months, 1 year? And is that a risk I wanted to take? These are the things we wanted to do along with crew optimization with the map as well.
Right, exactly.
What I do here is I hear this as a journey. I hear that
Yes.
it's going to continue to evolve to be better. I don't think it's going to evolve to be worse, and I think that that's important. Let me ask some questions from the participants here. This is with, and I once again, if you're listening to me, I guarantee you one thing is for sure, I'll butcher names. So don't take offense by that. What do you think about predictive maintenance technology? Like, I'm going to go with you, Jay, on that one. That is Lulia. And forgive me if I get that wrong, but what do you think about predictive maintenance technology? That's a question.
Yeah, absolutely. One of the key aspects of prognostics-based solution, which APM is part of in the overall portfolio, is looking at past performance, looking at your malfunctions, looking at your FMC analysis and all of that, and understand your past performance, and based on your current operating conditions, standard operating procedure, look at different failure modes. For example, if you look at a transformer as an example, what is my risk of exposure, probability of failure for my dielectric component, or my mechanical component, or my wear component, or high temperature component, right? So getting into the parts of it, or probability of failure for my bushing that is attached, right? So, and what is going to be the potential impact? So we are getting more into the asset maturity model, where traditionally we went from what was a descriptive analysis. Something went wrong, we analyzed, we fixed it, we recorded it, moving more into an optimized condition-based maintenance, and then looking into more of a predictive-based maintenance where you can optimize your O&M. We wanted to get more into what was essentially, the technology that came in from Japan, which is just-in-time maintenance, right? We don't want to maintain it all the time. Moving more into what is the risk of not maintaining your what if analysis, your scenario planning, right? So we are traditionally moving from a traditional space more into a predictive and a prognostic and a prescriptive kind of mode, which is basically what is going to happen to my equipment, when it's going to happen, what is the remedial action to stop that from happening, and if I don't do that, what is my risk exposure?
Yeah. And in fact, what is very cool about predictive maintenance technology that we have is that we can also do the prognosis of saying, if I know that this asset is not going to last more than 4 more months at full capacity, how much longer can I make it last if I run it at half capacity? Right? So you can take a generator and it tells you, okay, this generator is likely to start failing in the November timeframe if you keep operating at full speed, which is 1 megawatt. But if you were to run it at 500 kilowatts, it's going to last till next year, February. Now that's important because you may have maintenance coming in February already. So you could run it at a lower power and stress it out a little bit less so you can pull it further.
So you're able to run scenarios.
Yeah, you can run scenarios. Exactly. So that's called prognostics. And the prognostics are built out of very heavy physics modeling that has been worked upon for the past 10 years. It's not easy to get to this point. It wasn't easy for us, but now it's working. And once we have built this base and once we have that knowledge of the I think they call it stochastic modeling. Once you have built those models, to be able to extrapolate them for newer assets, that's fast. Once you have built the knowledge, recreating the same model for a brand new asset is not starting from scratch again.
Yeah.
So we have a leg up amongst many of our competitors only because of that reason, and that's why people keep coming to us for our predictive maintenance technology.
So you're and Z and Cheryl and Durand, I'll ask your questions, but so you're able to sort of pull in historical information to sort of paint a baseline picture of the health of your overall assets or whatever it might be, and then move forward?
Absolutely.
Mm-hmm.
Absolutely. We contextualize the data. So what we understand what the asset is doing and saying, but we can also go get third-party data. For example, you have a transformer that we have got IoT sensors on, and we are detecting its health in live conditions, but its oil may have been sent for analysis to a third-party lab a few weeks ago. Now that data happens to be outside of the transformer, and we can, because of our data integration abilities, we can connect to the third-party labs data sources, match the asset, associate the oil with the transformer, and be able to pull in those results and contextualize that transformer from a complete 360 degrees. So we created a digital twin of the transformer, and now we understand not just its innards, but we can also compare it with other transformers of the same make, which have been deployed in the similar area over the similar time frame, and understand what the differences are between those two.
See, I love it. Don't get me wrong. I think it's a fabulous approach to managing a very dispersed asset base. It's not within the confines of the wall. I mean, it's everywhere, and it's being exposed to different weather, different environments, different this, that, and other thing. I really like it. Okay, this is from Z. What intelligence does Vision AI have?
Oh, yeah, I'm also reading the question too.
Oh, then
Right.
just take my job.
Yeah.
Just take it right now. Just roll with it.
Yeah, I mean, he asked a good question. What
Yeah,
intelligence
it is.
I have? Will it tell me then an insulator is damaged, and can tell me that it may last about a week before I have a breakdown? And how is that different from flying a drone that takes pictures and analyzes them in the office? It's not different. Z, the only difference here is you are analyzing pictures by humans, but you have 10,000 of them per flight. So by the time somebody in the lab is able to take a look at those images, if you're going to look at them manually with a human being, it's going to take you months, maybe years before you can get this done. The computer vision AI programs will analyze 5,000 in about 200 milliseconds. And then it'll flag to you ones that it's not sure about, and you can step in.
Yeah. I think the AI component, I get it, I understand, but what it does from my perspective, I've got as a human to review all of this stuff, I can only look at so many. Yeah. And I need a way of being able to take that stack of information and review it, push the stuff out that I need to be aware of, and move the other stuff over here, because it's a great learning opportunity for my AI platform, or whatever my asset management platform that needs to know and goes into that system of record. I like it. I like it.
Yeah, the other thing, Scott, is limited capability with workforce as well. There's very few people with the specialized skill that can actually analyze. But with computer vision and standardizing, you are rolling out it across the board for your workforce, right? For your younger workforce as well, because it's a lot of this analysis very, very specialized. One of the challenges I had with the utility is the same thing, how do I know my top 5 high risk assets in high voltage assets in my infrastructure, right? So one of the things rolling out a solution like APM is like, why don't we do this? I'll do it with the solution with all the historical data pulled in from Delta X, as you say, for oil analysis data, and all of that automated. You do your traditional way, call all your guys, pull all of them in spreadsheets. And we did a comparison where the solution was able to give me the top 5 high risk assets, what are the risks, what are the maintenance actions, etc., within 2 minutes, versus took about a whole day.
Wow. Yeah, there you go.
Yeah, so that's the fundamental. And then the elimination of possible error-prone assessments as well.
Exactly. In fact, right there with the last statement, you talk about, I think I see a question from Amit here, but how does the solution incorporate false positives in the models? And that, Amit, is exactly how it's done. If the model is not sure, it assigns a confidence score. And that confidence score can be sometimes 90+% because it knows exactly what the defect is. And sometimes it's 45%. And when that confidence score is 45%, that's the cue for the human to get in the loop and take a look at it. And if it's a false positive, tell it it's not, this is okay, and this is not an error, or this amount of arcing that you see on an insulator is okay, and we can bear with it. That's when the model learns. Now the model learns that if it is a minor amount of arc or shadowing, you got to let it go.
Yeah, and for me, if I'm being directed as a human, if the platform is doing what it needs to do, identifying challenges, and then saying, hey, Scott, go out here, we see something going on with this insulator, go out and validate it. For me, I have direction and purpose on where I need to go, right? If it was just me going out there and doing an inspection, a visual inspection, I'm just looking. I don't have any, I'm just seeing. That's all it is. And the only thing that I can see when I was doing inspections is if the skirt is actually broken. It's broken. You can see it. I didn't see cracks. I didn't see the little nuances. I'm telling you that right now.
Right. You can fly a drone pretty close to these structures, get the images, and have the drone come back, offload its images and its data once it's at a docking station over Wi-Fi or Bluetooth or over a mesh network. And as soon as we have the images, our models get to work. So
Yeah,
we're
so
not involved in flying the drones. We're involved in getting the information from the drones sent to us. And that's when we take over.
yeah, and you're compressing the time. You're compressing the time from observation to possible action, right?
Yeah.
Or whatever the action might be. It might be a delay. It might be a reduction in whatever. However, you can extend that life of the asset.
Correct.
Z, I hope that answered your question because I was pretty geeked at the answer. Okay, this is from Cheryl. Cheryl's pretty active out there. Cheryl's on chat as well as Q&A. You mentioned integration, leverage of the asset management system, but do you also integrate and leverage live 3D visual models of an asset infrastructure? I'm not talking about GIS, ESRI data, but the privately maintained 3D models.
Yes, absolutely. We do. In fact, in the middle square here on the slide that's being seen, on the right side, you can see that we're looking at an image of a power substation. And we have a solution that can look at the substation and with cameras mounted on it, or a drone flies around it and looks at what the substation looks like. We can take that information and create a 3D model out of it. In fact, we do. We'd make a 3D model that can then be rotated in different angles, both pan and tilt or zooms. And you can teach the model, the computer model, to learn where to focus and where to read based upon what you created in the model. So we create the model, then we tag interesting locations to be zoomed into. And at the right time of the day, the camera will zoom in, pan or tilt, read the gauge, or take a snapshot of what it is looking at, and send that in a digital fashion back to the control office for a human being to take action if they need to. But the cameras are smart enough to learn how to pan and tilt and zoom based upon how the operator is using them. And yes, we do, in short, we do the 3D modeling of critical infrastructure such as bridges, railway systems, and especially substations, which is what we have started off with.
Wow. I hope that answered your question, Cheryl, by the way. And I was pretty happy with it. Well done, Shamik. I have to ask this question because Durand is in waiting. He was the first one to pop in with a question. And I'm going to go to you, Jay, on this one. Is energy harvesting the future of sustainable IoT?
It is one of the avenues. Yeah, sustainable IoT kind of fits hand in hand with renewables. Energy harvesting is one part of it as well. Yes.
I have to ask the question, what is sustainable IoT? Durand. What is it? Anybody answer? Jay, can you sort of define sustainable IoT? What is that?
Sustainability comes into, optimize low cost edge devices to an extent as well, because some of the equipment, when we started off, it was pretty expensive. Now we are able to use, your small scale drone cameras, small scale cameras and images to capture a lot of this, which provides for about 90% accuracy, right? One of the challenges I see with utilities, and I go and pitch with them, is if I'm able to provide you a solution that's going to cost 10% of what was an expensive infrastructure and provide you 95% of the features and functionality, would you consider, right? So that's one of the challenges we have. So how do I leverage it with low cost infrastructure, low cost rollout, but also cater to about 90% accuracy of what essentially would be a full on, very expensive solution. So that's one of the areas where a lot of utilities are looking at in terms of infrastructure, because we are looking at thousands of substations, millions of miles of infrastructure. What do we do, right? One of the key challenges is optimizing minimum O&M spend. Utilities hate O&M. Everybody wants to capitalize, right? So how do we minimize this and expand the footprint based on the same budget?
See, what I hear it, and there's a lot of commonality that exists within utilities just across the country and around the world. There's some commonality with assets. And so are we saying in this conversation that I'm pulling information from all types of source and making it even far more robust? Because I know down in Texas, it might be hotter than it is up on Maine, right? But there's some ways of being able to learn from all the other areas, right?
Yeah, and accounting for variances, one of the key things we look for is percentage deviations and variations based on coastal areas. We are doing a major rollout for a solution in Hong Kong. So the coastal areas in Hong Kong, there's a lot of impact to the equipments in the coastal areas, and we are accounting for that variations as well. The key thing is at the end of the day, right? We've got this technology space. We have the traditional enterprise applications, your asset management systems, or performance management systems, field management systems, etc. And then you add these technologies around image capturing, infrared imaging, edge computing, and all of them. The key part of all of this is how do we bring your enterprise application side of the house, the traditional ones, with this technology side of the house, which captures petabytes of data now, right? So one of the key things I saw is about 95% of all of the data information that was ever generated in this world was generated in the last 12 months.
Right.
So yeah, it's just a magnitude, right? That's where AI, computer vision all comes. We can't keep up to pace. There's, utilities in the Pacific Coast, your area, Shamik, right? They have so much data, they haven't done anything with it.
Yeah, they can't. Yeah.
So it's like I have petabytes and petabytes worth of images, but I haven't done anything with that, right? Yeah. So this is where, although there is initiatives, there is a lot of budget that's spent to capture all of this, we are not able to get to that on time. So the key part is, how do we use computer vision, get all of this unstructured data feeding into your asset management, asset performance management solution, feeding into more of a stack ranking. At the end of the day, it's all about stack ranking, right? What am I maintaining first? What is my risk exposure? What am I replacing first? Can I extend the life of this equipment with, as Samik said, underloading it, right? These are the use cases we are trying to address with leveraging all of this data coming from drones, images, video capture, infrared cameras, satellite imagery, etc.
Yeah.
I think it's cool. Yeah, I like it. I'm all giddy. All right. This is from Mazad. I hope I said the name, Mahzad. How is the digital twin of a transformer is different from the CFD simulations of it, which is physical based?
Oh, I got that. Yeah.
How is the
twin of a transformer different from a simulation of the transformer, which is physics based? It's not different. Mazad, I would say that the digital twin that we create is based upon physics-based models. So they're identical. But the difference is that instead of just a simulation, the digital twin gives you a visual that you can rotate in 3D, you can zoom in and out, and you can take a lot more information about it visually than you can from something that is pure simulation-based.
Well, there you go. Anything to add with that, Jay?
Yeah, absolutely. As Shamik said, one of the key things in terms of transformer assessment is part of building, repairing, reconditioning, servicing. We have analyzed about 4,000 failed transformers over the last 30, 40 years, right? All of the statistics correlation has been fed in as part of what has become a physics-based expert system, which caters to about 550 odd different data points, right? That any sensor you can, your core sense M10s to all of this monitors, Callistos, it takes into account different SCADA systems. And there is variations based on these different monitors as well, whether it's a 2-gas monitor or a moisture sensor, principles applied based on IEEE, IEC, CGRAE standards, moisture analysis based on Omen curve. So there is this wide array of correlations that's put in to pretty much account for any kind of vendor agnostic transformer, monitor, sensor, SCADA system, etc. And part of what we are doing with prognostics, take that and move into more of a asset strategy where, based on this past performance, what am I looking at in terms of my probability of failure in the next 6 months, in the next 12 months, based on your standard operating condition or adjusted operating conditions. That's the realm we wanted to, because a lot of executives now wanted to say, okay, I don't want to maintain it. What am I looking in terms of my dollars lost or in terms of my customers' impact, or in terms of potential outages, right? That's what they're looking at. Or if I'm spending $1 million, what am I saving in terms of my scores and all of those? That's where we are getting into in terms of using physics-based principles, but also using machine learning and AI with prognostic to project it out in future statistical modeling.
So you're optimizing with the data, you're analyzing all the data, it's all, but you're optimizing my capital and my maintenance spend, right? And making decisions accordingly. I know that capital and the treatment of capital dollars are different than maintenance dollars, but I know that from a utility perspective, the maintenance dollars and being efficient at spending those is critical, because in the past you just go out, do something, and then all of a sudden at the end of the budget year you're thinking, I have no maintenance dollars, and then you start to make the decision like, I'll just sweat that asset. I don't know what's going on over there, but I'll just sweat it. That's when the problems truly occur. This is from Alex. What infrastructure is required to support mobile applications that take the camera to the data source? I don't know. Which companies are at the leading edge of these types of deployments?
Oh, Jay, I can go first because I had an interesting conversation at a trade show just 2 weeks ago, where in Texas, where somebody came up to us and said, we operate drones for utilities and companies that are doing maintenance for utilities, and they make and sell a drone and the flight software that goes with it to control it. So they can sell you a pre-programmed with a flight path drone and the machine itself that can then go and do those analysis of those images. So there are businesses propping up that are doing that. We at Hitachi, we are not a drone company. So, or we make some cameras, yes, but we're not a drone company, and we're not into the business of going out and flying the drones ourselves. But we are working with several utilities that have already invested in FAA certified beyond line of sight drones. So the FAA has given licenses to some drone companies to be able to fly multiple distances, so that it's beyond line of sight. So you don't have to physically stand under a tower to fly the drone. You can pre-program it to go out and fly several kilometers and come back on its own. And that way you could gather a lot more images from a lot more towers.
Yeah.
Well, I was going to ask that line of sight question. So the FAA is granting that, because that's pretty doggone cool, right?
Yeah, exactly.
Yeah.
I hope that answer. I hope that answers your question.
Just to add to what Shamik said, in addition to drones, that's one area, right? We are looking at other. So we work with a lot of third-party companies that provide infrared cameras. We do quite a bit of that infrastructure as well. So look at temperature differentials in substations, pan and tilt capability. One of the cool features we looked at is the toy dog with Boston Dynamics, and a lot of utilities are tagging along with them. That's demonstrated, where it basically does zoom to an extent where it captures about 90%, except for the top part of the infrastructure, right? And we are able to capture bushing leaks, if you will, crack sheds, if you will, a lot of those images, and that feed into the overall assessment, right? That traditionally requires a lot of manual manpower, if you will. One of the other use cases we are looking at is measuring the conductance on a line, right? So you have this remote equipment that goes across the line, specific sections over a period of time, that automatically feeds part of a conversion of that data and the waveforms into the overall assessment of the line, the segment, and the quality as well. So we're looking at a lot of those use cases, not just in the substations. We are looking at lines assessment as well, and a lot of those other imagery.
Yeah, I have a quick question. How do you define asset criticality, provide a rating to it on a asset base that goes everywhere? How do I determine that transformer, that bushing's more important than that transformer, and so on? It would seem to be a challenge, but you would have to have some sort of criticality rating of your asset base. Am I correct on that?
Yeah, absolutely. So the first rule of thumb is any transformer, irrespective of whether it's high voltage, medium voltage, or low voltage, that serves my house is the highest criticality. right? Anyways, jokes aside, there's a lot of factors. There's a lot of factors that feed in, right? So one of the things we look at is the number of service delivery points that is attached to an equipment, as an example. Public vulnerability index, the number of arenas, hospitals, schools, etc., that's served within a square mile radius of that particular high voltage equipment, as an example, right? The restoration time it takes, depending upon the location, and then the restoration cost that goes with that, and the replacement timeline. These days, you're looking at a year if you wanted to replace anything for an high voltage. Even distribution class transformers, we are waiting for 8 months these days.
No way.
Right? So there's a lot of factors. Topology is one factor that feeds in. So the way we traditionally do it is we have about 20, 30 different factors that feed in. And we look at the dynamic load as an example, the voltage class as an example, the age of the equipment as an example, right? And then whether it is supported, right? So a lot of those factors feed in what essentially becomes a weighted average kind of framework, where utilities use that. Again, one size doesn't fit all, but
it doesn't. All I could think about is the culture. And every time I was sitting in a conference room and we were talking about this transformer being important, and these are the reasons why, versus this transformer being important and not as important, there's always friction between, oh no, that transformer is far more important than that transformer. Oh no, oh no. And you have to remove the human element and make it so just like, nope, here's the reason why you agreed to this. Here's the reason why. And because it becomes a Donnybrook in those conference rooms when you start talking about, these assets, right?
Oh, yes, absolutely.
That's my favorite transformer. Yeah, there you go.
I mean, it need not be static as well. Gone are the days where we do an assessment of criticality one time and that stays. No, these days criticality assessment is so dynamic based on a lot of factors as well.
Hey, here's a question from Amit. How does your solution incorporate false positives in the model?
Oh, I think I already answered that. I remember I said assigns a.
What part of the process don't you understand, Shamik?
I just trying to preempt you by saying that I tried to address that by saying that the model will give you a low confidence score if it detects a false positive, because it understands that it doesn't have a high confidence in it. And when that happens, the human in the loop gets involved, and it trains the model further by saying, nope, that's a false positive, or I don't care about that result.
There you go. Have you answered any more that I can be aware of?
I don't think so.
Negative. All right. All right. I'm gonna hopefully Deshaun, I hope that I got that right. Can you comment on the importance of creating an extremely simple user experience for the user to be able to use one or more of these advanced technologies capabilities, given how overwhelming technology can be to facilitate our operational teams? That's a great question, because I know that I get overwhelmed easily.
Yeah, no, it's easy. Dishan, the way we do that is, I think, take a simple case of a substation monitoring facility with cameras. You can do that by installing fixed cameras, looking at fixed equipment, like in the view that you see in the middle of the screen here. It could be a thermal camera as well, or even LiDAR based. You can take a look at what's happening, read the gauges at a certain time. You can zoom in or out, and you can also have things, some very simple solutions like a loudspeaker that automatically goes off if a burrowing animal or a bird comes to start building a nest somewhere. And these are solutions that we have deployed with customers live in the field today.
Yeah, I think he's bringing up a good point, and the point is can I hear this? You guys at Hitachi hang around the water cooler and you come up with new use cases, and you're saying, yeah, that technology overlaps with this technology. We got a new, but for me, field individual, I see the value. Where do I start? What do I do? How do I achieve success when all of this stuff is over here, and then keenly focus on what I need today? Yeah. That's a conversation, right?
That you have. Conversation is a good question too. How do you prioritize it? What's a simple way to, get somebody convinced to invest in a technology like that. I think you pick up on one thing, like let's say you're going to look at transformers within a certain, not transformers, insulators on a certain transmission line,
Yep.
and solve just that problem. So let's say the goal is eliminate helicopters. We no longer want to fly helicopters out with people with cameras trying to peer out of them and taking photographs. So if that's one goal, you can address that by using image-based technology, which uses either a drone or ground-based crews that can take those photographs, or satellite-based, and use that to solve the problem.
Yeah, I do like that. And it gives me a level of comfort because I know I see the vision. If I want to go down this digital transformation, journey, I've got to have those the trusted Sherpas to help me through it. It can be overwhelming, and if I make missteps in the beginning, I get frustrated, and I won't benefit from it. So it's important that you find, definitely, it's just me, trusted Sherpas to be able to take you on through this journey. Okay, we only have a few minutes left. I'm going to rapid fire some questions here. Did that one. This is from Scott. What kinds of ML models do you build beyond image and video analytics? How do the physical models interact with them? I don't know.
Jay, I think Jay explained that over the transformer, but Jay, do you want to talk a little bit about the transformer models that you build?
Oh, yeah, absolutely. Yeah, our transformer model is physics-based model based on statistical correlation. Projection is based on statistical modeling using Markow's and Bayes principles, right? So that's what we do, the stochastic models, if you will. And in terms of prognostics, we analyze large sets of data, particularly when it comes to your streaming data, right? When we get into the realm of generation, where we are looking at a lot of those historian data, vibration data, acoustics data, and all of that. So we use a lot of those machine learning principles, statistical modeling, to come up with patterns, and over a period of time, as the maturity increases, we just standardize it as part of what becomes a model library. So from a categorization point of view, it all depends on the volume of the data and the type of the equipment. When we look at traditional transmission power equipments, for example, a frequency and the volume of the data would not manifest really well into a machine learning, where you'll be looking at a lot of false positives, which is one of the bad experiences we get into. It always needs to be optimized based on the equipment and the volume of the data we are looking at. There is no point doing ML-based analysis, but for your distribution equipments, where you're looking at an inspection once every 3, 4, 5 years, right?
Yeah.
You do not have enough data to do any correlation or any statistical modeling per se. But when you look at partial discharge, for example, where there's large volumes of data, right? There's a use case that manifests itself to an ML modeling, because there is not a lot of historical data and expert modeling, because these are new, right? And talking about the previous question, which is kind of related, is how do you optimize use cases? There is a lot of peer pressure, right? Every utility wants to do what the other utility is doing. I don't want it to be left behind. That started from when we were teenagers, right? Any activity for that matter, I don't want to be left behind. The key is identifying what my challenges are, what my use cases, focusing on a very simple use case that provides value. Based on the large volume of data we need to do an analysis of what equipment or what part of a business where we feel confident about data that provides immediate value, that will provide management's buy-in in terms of additional investments as we expand. So we have seen a lot of utilities look at a big bang approach, doing digital transformation from anything to transformers to EV charging units to everything. And 3 years down the line, they're like, we don't know what to do now.
Yeah.
Now we're going to have to wrap it up. Ian, Scott, Brian, and others. And I want to say Nestor and Hari, sorry we couldn't get to your questions, but I would like to sort of, for the remaining minute or so, Shamik and Jay, sort of give us a wrap up of just the overall conversation we've had here. Just sort of summarize it up.
Sure. I can go first, Jay, if you don't mind.
Yep.
It might even address maybe a question or two that's already here. Let me just tell you about some use cases. So we've done, along with Hitachi Energy over here and Jay's help, we have wind turbines in the offshore locations that are equipped with sensors. Many of the sensors are not battery operated. So I do not believe that battery operated sensors are going to have only a limited shelf life. Even if they are, batteries, based sensors can last for decades now, or they can be recharged through renewable sources as well. We've been implementing wind turbine predictive maintenance for many years now, for many hundreds of them at once. And we're also doing things like wildfire management, risk management by implementing sensors in Australia on wooden poles and detecting using gyroscopes when they might fall over. So we can detect the tilt on them.
Yeah.
And by using an anemometer, we can check what the wind speeds are. Wind speed and anemometer-based sensors are now being used by utilities in my neighborhood in California on the West Coast, where they will emergence in a high wind event will automatically shut off power to many people. I've lost power once in the past 5 years because of that. But there was a high wind event somewhere close by to my house and they shut off power to my house. It was inconvenient, but that's okay because we'd rather not have a wildfire. So I think IoT solutions have been used for asset management, for preventing wildfires, for addressing climate change problems and everything else. For a number of years now, the utility industry has always been on the cutting edge of IoT.
There you go. Jay, 1 minute.
Oh, yeah, absolutely. Just to add to what Shamik said, right? Our key objective here, with the solution space is to not to rip and replace any of the existing practices of any of your IT or OT solutions that you have in place, whether it's your asset management systems or your SCADA systems or communication devices. It's basically leveraging and adding on to it. So the spectrum lies between, okay, we are not having that asset maturity model or the maturity to get into this transformation program versus the other spectrum is it's driven mostly by the IT organization where they wanted to trial without properly defining the use cases. The key part is to strive for excellence, venture into it, focus on your key use cases, and then lead from the front. Because at the end of the day, things are changing by magnitude, and it's always worth the risk to try it. You always can err on the on the side of making a decision instead of not making a decision. We want to be the leader in the space, right? So when I look back at a lot of the stuff I did initially in the asset performance management space 10 years ago, I laugh at myself and I'm like, how stupid of you. But then again, that's what has led to where I am right now in terms of looking at a lot of this, marrying this technologies with the asset performance management enterprise applications. So we are at the realm of a lot of things in terms of computer vision, AI, and the ability to optimize. The two primary objectives we are looking at, O&M and capital replacement. And these tools provides a great avenue for us to do that, all along increased reliability and safety.
All right. And I want to just thank you to the panel. Great job. Enjoyed the conversation. I think the future is exciting. I like it. And I just can't wait for what next year is going to bring and so on. All the participants, thank you very much for joining. The questions that have been posed, I'm sure that we will provide answers going forward. I highly recommend, as much as I can, to connect with Jay, Shamik. If you have any additional questions, they are an absolute open book. Excellent job to IIoT World for pulling this together. The utilities, it's a brave new world out there, and I'm just excited about leaders like you to be able to do what you do best. So thank you very much for joining.
Thank you, guys.
Thanks, guys. Have a good rest of the day.
Love the questions.